obtain the general solution for this equation. What I see here is if we simply move the y over x on the left hand side, this looks like the linear first order equation. So I will do that. I subtract y over x on both sides, and we have that. So this looks like a linear first order equation in the standard form. So I will write the standard form. So that equation in the standard form. So when we compare this, p of x is negative 1 over x. So we write that out because we will need that for integrating factor. So from these two, we have p of x is negative 1 over x. So integrating factor for the standard form mu equal to e to the integral of p to the x, e to the integral p to the x. So mu will be equal to e to the integral of negative 1 over x dx. Integral of that will be e to the negative ln of absolute value of x. And we can move the negative 1 in front of the ln inside as the exponent. E and ln can cancel out, so we will have just absolute x to the negative 1. Or we can write 1 over x, and let's just put absolute value around it. So that is the integrating factor. What we do is we multiply this on both sides of the equation in the standard form, meaning this one. Right. So I'll do just that, but I will write the integrating factor. Let's just put that in different color. Change that to purple. So this will be the integrating factor. So we have absolute values of 1 over x. There will be, I will change just a little bit later. So we have dy over dx minus that absolute values of 1 over x. And then I will rewrite, instead of y over x, I will write 1 over x and y in that form instead. And on the other side, I have negative, still the integrating factor of 1 over x, and then 7x plus 1, of course, in the standard form. So 7x plus 1. Now, this is the nice part. So we pretty much we multiply the absolute values on both sides, but in reality we do not need to, because if we remove the absolute values, I will do that. Instead of the absolute values, we can just say parentheses, we can write plus or minus, and this we can write plus or minus. I just put plus or minus here instead, and so that will be just plus or minus, because absolute values 1 over x could be positive, could be negative. So we may have plus or minus, I should say positive of 1 over x if it is positive, or the negative. If 1 over x is negative, we have the opposite sign, so the absolute values, the whole thing will turn to positive. Right. Notice that we have plus or minus on both sides, so we just cancel all the plus or minus on both sides. So bottom line is, instead of multiply by the absolute values, we just multiply by 1 over x, meaning without the absolute values. So pretty much the absolute values is not necessary, we just multiply 1 over x. And that minus 1 over x squared y, and we have 1 over x on the other side, 7x plus 1. Again, if we have plus or minus on both sides, we cancel, and so that doesn't really matter whether we have absolute values or not. I just cancel out on both sides anyway. So that's what we have here. All right. So the linear first order equation, we know that the left hand side will be just, I should say it, the left hand side will be just, all of this when we combine will be just mu times y, derivative of that. So what we have on the left hand side is the product rule, which is just mu y, mu times y. In our particular problem, we will have 1 over x times y, derivative of that. The right hand side, I will multiply it out. We have just 7 plus 1 over x. To undo the derivative, we just integrate. So we have 1 over x times y equal to 7 plus 1 over x. We integrate that. So 1 over x times y equal to 7x plus ln of x plus a constant c. Now we just need to get y by itself, so I will multiply x on both sides. Just write a little note here. Multiply x on both sides, so we will have y equal to, multiply by x to 7x, we have 7x squared plus x times ln of x and plus cx. And that is the answer for the problem.